Here we go with rational expressions and functions 4.5. So this is just got some more addition and subtraction problems. Just gonna practice them up. So let's get to it. Now remember, the whole point with adding and subtracting these rational expressions is getting those common denominators. And that's really what makes it the toughest part, because once you have the common denominator, it's usually fairly simple. Okay? So the first thing we check is the denominator. If it's the same, we just combine it and leave it, right? And then we take a look at what's going on with the numerators. So I've got 5y plus x minus 5y. So 5y minus 5y would cancel out, so it would be left with x. Now, if we don't have any plus or minuses, we can look to canceling. Because this is all multiplication here, we can cancel one set of our x's. Now, if we get rid of this whole thing, remember, it's like it's multiplied by 1. So we leave a 1 there. We'd have 12xy left over. That's what our answer should be. Okay, on number 2, once again, we've got our 12x's. So we just leave 12x. Then we go x minus 2x, because we're combining like terms. So we get a negative x plus 2y. Now, because this one has a plus, we can't get rid of the x's. It's always got to be multiplication. So that's as simple as we can get it. So, now if we look at these ones, they don't have common denominators, do they? So how can we make these ones common denominators? Well, the easiest way is to just multiply them by each other. So I'd multiply this side by 3, and multiply the right side by 2x squared y, giving me a denominator of 6x squared y. That's our common denominator. Then we go 3 times x, 3 times 6, plus 2 times 2 would give us 4, x times x squared, x cubed, y. Now we don't have any common denominators here, and we don't have anything that they're sharing. Like if they all had an x, we could try to eliminate an x. Or if they all had a y, we could eliminate a y. Because they don't, we would just have to leave it like this. Okay, now on 4 it's a little easier, right? Because they share 5 here, but they don't have a v squared on this one. So we need to times this one by v squared. So we times the whole thing by v squared. So we get 6u v squared minus 2u over 5v squared. Now, if I wanted to, I could pull out a u, but that's not really going to get us anywhere. Okay, if we would have been able to pull out a v squared, that would have been great. But because we didn't, we don't really need to do that, and we can just leave it like this. By all means, if you really want to, you can do that, but you don't have to. Alright, now we're getting a little more complex. Okay, but we still look at this and we say, okay, I've got a common denominator, so I'm going to leave it just like that. I could multiply it if I wanted to, but we don't usually do that till the end, if at all. So m plus m would give us 2m. 4 plus 5 would give us plus 9. Okay. Now, you may have been thinking, well, could we have canceled some things first? And, yeah, we could have, if we really wanted to, we could have, but the problem is, had I canceled that out and that out, we wouldn't have had the common denominators, and therefore we wouldn't have, we would have ended up with 1 over m plus 5 plus 1 over m plus 4, which we would have just had to go back and do this, multiply by the same things. So, because we have to have those common denominators, that's why we couldn't really cancel out to begin with, even though it looks like we could. But there we go, that's what we're left with. If you wanted to, you could have made this, multiplied this out, and gotten a denominator of m squared plus 9m plus 20 under 2m plus 9. Either one of those works. I would just as soon leave it as factored, especially because what we get into is we're dealing with, when we start graphing, we really want to to have it like that. Okay, number 6, once again we already have the common denominators, so I just subtract. So m minus m, that would cancel out. Negative 2 minus 2 would give us negative 4 over 30m minus 1. Now, 4 is like negative 2 times 2, 30 is like 2 times 15, so I could cancel out a 2 and have negative 2 over 15m minus 1. And if I wanted to, I could distribute that 15 and go to negative 2, 15m minus 15. Both of these would work. Okay, so once again, we first start off by checking the denominators. If they're the same, we just rewrite it. And then we combine things. 6b minus b will give us 5b. 1 minus negative 1 will give us a positive 2, right? Because minus and negative is really plus. So I can't really do anything else to that. If I wanted to, I could have pulled out a 4b on the bottom and had b minus 6. But that doesn't really help me, right? Now, had this been able to become, 5 times b minus 6, then we would have wanted to do it. But because it can't, we don't really need to take that extra step. Alright, even though it's quadratic on there, it's still a common denominator, so we just keep it as it is. Deal with the top. 6a, no other 6a, so we just write 6a. Negative 6 plus 3 would give us a negative 3. So I could simplify the top, right? Pulling out a 3. I'd have 3 times 2a minus 1. And I could try simplifying that bottom. Factors of positive 2 that make negative 3 would be a minus 2 and a minus 1. See, we almost were able to get rid of 1. So, it was useful to try that, but you could have just left it like this because this doesn't eliminate anything. The only reason we want to end up factoring things out is to see when we can eliminate things. That's really the only reason. Alright, so now we've got some more that don't have common denominators. So let's scoot this over a bit. So m plus 1 and 3. So I need to multiply the right side by 3 and the left side by m plus 1. That will give me that common denominator of 3 times m plus 1 over 2 times m plus 2 times 1. Then that negative, that negative would apply to both of these. So it'd make that a negative m plus 1, so 3 times negative m minus 3m, then positive 1 times 3 plus 3. So 2m minus 3m would give us negative m, plus 2 and 3 would give us 5, over 3m plus 1, which I can't simplify and pull anything out, so we just leave it like that. You could write it 5 minus m if you didn't like that negative m, but same thing. You could even multiply that 3 through and get 3m plus 3, but you don't have to. Alright. Now let's pull over number 10. Same idea, 4v, v plus 3, so we need to multiply this by a 4v. We need to multiply the left by v plus 3, giving us 4v times v plus 3, which I could multiply through, but I like to leave it factored at first. Then 6 times v, distribute, 6 times 3, 18, 4v times v, 4v squared, and then 20v. So we can combine like terms. We end up with 4v squared because we like to write the highest degree first, plus 26v plus 18 over 4v times v plus 3. Okay, then if we really wanted to get crazy and check, see if we can eliminate anything, which we should, we can try to factor that 4v squared plus 26v plus 18. So it would be Superbach's method, 18, 4v squared. Then we go 4 times 18, giving us 72, Are there factors of 72 that add up to 26? Let's see, 3 and 24 were close. 4 and 18. 6 and 12. But none of these are adding up to 26, are they? 7 didn't work. 8 and 9. Yep, doesn't work. So we leave it that way, or yeah, we can't even pull out a 4 or anything. So we could multiply that and get 4v squared plus 12v on the bottom, but you don't have to. And just remember, that doesn't mean you can get rid of the 4v squareds, because you have these pluses. If it was multiply, you could, but when it's just plus, you can't. So we can just leave it like that. Alright, moving on. So, now we've got x minus 1, x plus 1. I don't think you can just multiply by a negative 1, because it wouldn't work. So we multiply by each one, and by x plus 1 here. So I get x plus 1 times x minus 1 as our denominator. Numerator 6 times x plus 6 times 6 plus 4 times x minus 4 times 1. Combine like terms and we get 10x plus 2 over x plus 1 times x minus 1. Could I pull out a 2? Yeah, but that really wouldn't help me, right? So I can just leave it like that, or I could even, multiply the bottoms and get x squared. Let's see, then that would be x minus 1 and x plus 1, so x squared minus 1 is what you end up with. But you don't have to. Okay, 12. Same idea here. We're going to multiply by x plus 5 on the right. We're going to multiply by 2x minus 3 on the left. And that's going to give us a common denominator of 2x minus 3 times x plus 5. And the numerator, 4 times 2x, would be 8x squared minus 3 times 4x, 12x. Now think of that minus as a minus 2x. So negative 2x times x would be negative 2x squared. Negative 2x times 5 would be negative 10x. So then combine like terms. 8 minus 2 would give us 6x squared. 12 and negative 12 and negative 10, negative 22x. I could factor out an x, but that's not really going to help me. So I can just leave it like this. Alright, so now we're getting more complex denominators. These ones are still common denominators, so we just add. V and 6v give us 7v minus 6 over 6 times v plus 1, v minus 1, which I'd probably just leave that way. Yeah, I could turn that into v squared minus 1, because that's that difference of squares, because that would be right, v squared minus 1v plus 1v minus 1. So those would cancel. Then I could turn it into 6v squared minus 6 over 7v, or under 7v minus 6. But either one works. The main point is that you're keeping the same denominator on these ones that we don't have to change, or changing it to be common. And then dealing with the top. B minus b would give us 0. Negative 5 minus negative 4 would give us a negative 1. Right? Negative 5 minus negative 4, that's like plus. So we'll call that good. Leave it like that. Don't make these too hard on yourself. Alright, same with these ones. Still have common denominators. So we just x minus x, got rid of that. Negative 6 minus 4 would give us negative 10 over 6x cubed plus 42x squared plus 36x. Which, yeah, I could simplify that, but I don't need to, because I'm not going to get rid of anything. Okay? There's nothing that I can eliminate, so why? It's not really worth it to just rewrite the equation. Okay, 16, same idea. We've got 5p squared minus 10p minus 75 under p plus 2p would give us 3p minus 2. Now, could we end up with a 3p minus 2 here? Maybe. But I could pull out a 5, couldn't I? So we'd have 5 times p squared minus 2p minus 25. Factors of 25 that give you negative 2. 5 and negative 5, and 1 and 25 are the only ones we have, so that's not going to help us. So let's leave it like this. Alright, now we've got to get some like terms going here, right? Some common denominators. So this is where it gets tricky, especially when you have ugly ones like this, and nothing else is shared. So basically you have to go 2 times m minus 2 times m minus 6 here. Do the same on the top. And we times this by 3m. So we end up with 6m times m minus 2 times m minus 6 on the bottom over 3m times m is 3m squared. 3m times negative 3, negative 9m. Then 6 times that would be plus 12m minus 2, m minus 6. Okay, now we've got to do some simplifying to get these combined. So notice this and this are the same, right? So if I multiply one, I've multiplied both. So m times m would give us m squared, then negative 6m, then negative 2m, then positive 12. So that'd be negative 8m. So I'd get 3m squared minus 9m plus 12 times m squared minus 8m plus 12. And then we'd have 6m times m squared minus 8m plus 12. Because that'll multiply the same as that. Now you may want to try to eliminate those, but you can't. Because of this plus and this minus. So don't even try. So now we go 12m squared minus, what is that, 96m plus 144. And we've got 3m squared minus 9m. So the top would become 15m squared and negative 9, negative 96 minus 105m plus 144 over, then 6m times that would be 6m cubed minus 48m squared plus 72m, which that's what I would call it good. I'm pretty sure I can't factor any of that to just to have it be the same. I suppose if you really wanted to, you could graph them both and see if they intersect. Maybe that, if they intersected a y or an x-intercept, that would probably work. But I think that's good enough. Okay, because that's quite a bit of work, isn't it? Alright, so now number 18. So, same idea, we've got to get the denominators the same. So we multiply that by each other, so x plus 3 over here. And then we'd multiply by 6 and x minus 5. So we'd have 6 times x plus 3 times x minus 5 here on the bottom. Then 3x squared plus 9x plus 3 times 6 would be 18x times x minus 5, which I'd want to distribute that through. So we'd get 3x squared plus 9x plus 18x squared minus 18 times 5 is 0, 4, 90 minus 90x. Then combine those like terms. So 21x squared minus 81x, because positive 9x, negative 90. Okay, all of that over 6, x plus 3, x minus 5. Now I can actually pull out something that I could eliminate here. We can pull out a 3, right? 3x, and we'd end up with 7x minus 27. over 6 times x plus 3 times x minus 5. And 6 is really like 2 times 3, so I could get rid of the 3's. I'd be left with x times 7x minus 27 over 2 times x plus 3 times x minus 5. Now, you may not think it's necessarily worth it to go to that length, but you can. Sometimes that can be helpful. Sometimes there's more that we can eliminate, but in this case we can't. Okay? So, the last two here. So, kind of the same idea. So we times this by r plus 2, times the left by r minus 4. Do it to the top as well. So we get 2 times r, so 2r minus 8 plus 2r squared plus 4r, which is the top. So we combine like terms and put them in order. 2r squared plus 6r. So 2r squared plus 6r minus 8 over r minus 4 times r plus 2. Okay, now we would want to look to see if we can simplify that top. So 2r squared, negative 8. Negative 8 times 2 would give us negative 16. Can any of those add up to be a positive 6? Yeah, negative 8 and positive 2, right? So 2r minus 8 and r plus 1. Which unfortunately none of those match up, right? So you could have left it like that, you could have made it like that, or you could even have multiplied the bottoms and left it like that. Okay? Alright, let's take a look at that last problem now. Same process. Do v minus 3, do v plus 3. So we end up with 4v squared plus 12v. Then think of that as a negative 2. So minus 2v plus 6, which we simplify to become 4v squared plus 10v plus 6 over v plus 3 times v minus 3. So the first thing we want to do is try to factor that to see if it can factor and to see if we get v plus 3 or v minus 3. Because if we get that, then we are doing awesome. So factors of 24 that could add up to 10. And they have to be positive. 6 and 4, right? Again. So 4v plus 6 and v plus 1. Which they don't, do they? So once again, you could have left it this way. You could have left it this way. And the third way would have been to multiply that. So v squared minus 3v plus 3v minus 9, which those cancel out, so we get v squared minus 9. And you could have written it 4v squared plus 10v plus 6 over v squared minus 9. Okay, 3 different ways we can write it. They all mean the same thing. So, by all means, pick which one you liked and use it.